will be easy to apply image augmentation in Keras because we have the code and we will just edit the image data generator function. And in our work, from the imbalance part, in our current work, we have less amount of data, and we applied transfer learning, and we got a very good accuracy with that. However, we want to apply data augmentation and get better accuracy for our problem. Well, let's go back to the documentation of Keras, and there are some modes here, and you see that there are parameters here. And let's say that we want to apply ZCA whitening, and to do that we need to say that we want to apply ZCA whitening, and it will be equal to true. And for the parameter of it, let's do the same with documentation. I won't touch it. And for the rotation range, for the random rotations, I want to rotation range. I want to rotate images up to 45 degrees. The reason is I also want to apply horizontal flip and vertical flip. Uh, Vertical flip. So this will be the same with rotating images in 360 degrees, 60 degrees. But the advantage of it, if you apply like that, if you delete it and if you say that 360, it will always rotate the images, and it will apply this ugly random filling. This is not a good thing, I think. So to apply flipping and random rotations, I want to do it like that. I hope I was clear with while explaining it. And also let's go to documentation and see the parameters. Let's add some brightness to our images, and well, let's say that, sorry, we won't be touching the brightness. I saw some problems of brightness range online, so I don't want to um, deal with any other problem. Well, we can shift our images with height shift range and width shift range. And this, let's say that we can shift images with 20%, and for the width shift range, let's apply the same principle. And also, we are done actually. This is for our training images, and if you want to apply these techniques to validation data, it's up to you. You can do that, but I think that for the validation part, you do not want to apply data augmentation, because these are original images, and maybe you want to apply augmentation, like some kind of augmentation like that is not rare, that is rare on the real life, because there are no images in real life like that. There are If you apply these techniques, you shouldn't apply data augmentation to your validation dataset, because it is your real data, and you want to test your data, you want to test your model in the real life cases. So you shouldn't be applying data augmentation for validation. But if you have less data, you can apply some data augmentation uh, like flipping or cropping, because if you crop image, maybe let's say that if you crop this image like that, it's still a real life example, but this is not a real life example. This is not the thing that you can see on the real life. But the reason to apply these techniques are just for increasing the accuracy of our convolutional neural network model. Well, we are done. I hope that we have problem, and well, in this problem we have imbalanced dataset problem, and to solve that, image augmentation is one of the uh, way of coping with that. But in that moment we are generating images, but there are still some problems here. So we have 1000 images for cat class and 300 images for dog class. Well, while applying data augmentation, we can do uh, we can indicate that uh, augment the data with some likelihood, augment, let's say, 25 images from dog class, 25 images from the cat class, or we can apply class weight solution here. And to do that, uh, to do that, so in alphabetical order, uh, we need to say that 0 indicates 0 means cat. Uh, for its class, we need uh, 0.3, and for the one, which is dog, we need 0.7. So now we will be using class weights. I hope there is no problem here when we have some problems here. We forgot the comma. When we apply image augmentation with class weights, we will be doing image augmentation and transfer learning to it. And uh, let's see uh, some some EPO here. Well, the augmentation takes times. It takes times. So we have some problems here. Cat means 0, dog means 1. Well, let's see the problem. Feature wise center, but it hasn't been fit on any training data. And let's check for that. Well, it's working, and the problem is actually we can't use ZCA whitening with feature wise center. This is the problem. So normally, let's check for that. We have uh, well, let's see the documentation. Uh, we have feature wise sample false, so we have problem here, and let's check for it. Well, it's not a problem for this case. If you want to apply feature wise center and ZCA whitening, uh, you need to do some other processes. However, we are now applying uh, rotation, and why we fixed it to the 360. Let's say that 45 for the other work. we have the data augmentation here. Our computer is working on that with transfer learning and data augmentation. So for the data augmentation, I can say that it takes more time because it will firstly randomly augment the data according to these parameters, because it doesn't apply the same uh, well, it applies, let's say that it applies rotation range, but it applies it in 43 degrees, but for the other turn it applies in only 7 degrees. Or it applies horizontal flip for image, but for the other turn it cannot, the horizontal flip is not an option. So these are random things. If you say that it's true, it will apply or not. So it will actually, this is the reason that uh, you can apply augmentation, and it increases your data. So in one turn it flips in horizontal way, but not in vertical way, and the other turn it flips in vertical way, and in the other turns, let's say that it flips uh, both horizontally and vertically, and also it applies rotation range, but it applies it for every image. So, and also it resizes it. Image data generator function resizes the images. So these are the processes that increases your time, but also augmentation increases the variation, and it increases the variance of your data. It means that it will be time consuming, more time consuming to uh, understand the variance uh, when I talk with the mouth of convolutional neural network model or convolutional neural network model. So in 7 epochs, these are not good results, I know. But if you apply and continue, you will get better accuracies. Well, this is the way to apply data augmentation with Keras. It's not that detailed. I mean, it's not that hard. It's not that aggressive. But for the aggressive part, we will go into the imgaug library and we will apply the techniques of imgaug library, and we will do aggressive data augmentation with this library.